Hello, we are Group ENVE 5, and we are working with the town of Stratford to design a BMP for a public parking lot, specifically the Frank DeLuca parking lot. My name is Esther, and my group mates is Alex and Sarah, and our objective was to investigate a few different types of BMPs that we could install to the lot as well as the lot adjacent to the Frank DeLuca parking lot. So throughout this presentation, we're going to be talking about bioswales, rain gardens, and vegetative surfaces.
This is an aerial view of the two lots that we worked on for this project, the Frank DeLuca parking lot and the vacant lot adjacent to it. Some things we had to keep in mind for this project were the proximity to the wetland and the Housatonic River. This allowed for limited space underground and eliminated potential BMPs like pervious pavement, which we initially considered at the beginning of this project. The town of Stratford has plans to repave these two lots, and because of their stormwater permit, are required to implement BMPs to control the runoff on the site. This is where our project originated. Because we needed to design these BMPs to meet the requirements of the Stratford stormwater permit, an important element to keep in mind is the water quality volume for the lots. Water quality volume is the amount of runoff generated for a 1-inch storm event, and any BMP we needed to design had to have a storage capacity great enough to handle the water quality volume for the lots. Using the GIS software for the town of Stratford, we were able to come up with water quality volumes for the DeLuca field of 365 cubic feet and for the vacant lot 389 cubic feet. These values will be crucial in our sizing and design calculations.
The first BMP that we're going to be talking about are rain gardens. So in this image, you can see that this is an aerial view of the Frank DeLuca parking lot, and we sectioned off in the yellow perimeters where we thought that the rain garden should go. The images on the left shows you the different pictures that we took of that specific section because there was always a pool of water there even when we went on our first visit. So when we came back, we brought an auto level with us and we took different elevation points, which is depicted from this picture. You can see the different distances and angles that we took each point at to the chart to the right, and you can also see the elevation differences for each point. So we specifically highlighted 10 and 11 because that is where we thought that the rain garden should go, and it made sense because it had the most significant elevation difference there. And that is also where the flooding happened, so the data made sense.
This is a cross-sectional view of our rain garden design. The inlet structure is made up of curbs with curb cuts, followed by a vegetative slope, which leads to the ponding area. The maximum ponding depth of 1 foot is maintained by the overflow control structure, which ties into the existing catch basin on site, allowing the rain garden to store the water quality volume for the site without flooding during larger storm events. The mulch and bioretention media layers allow the runoff to be stored and treated as it makes its way through the bioretention cell. The required 2 feet between the top of the water table and the bottom of the bioretention cell is maintained. The pond dimensions are 25 feet by 20 feet, and including the vegetative slope and the curbs, the bioretention dimensions are 34 feet by 29 feet.
Another BMP we decided to implement in the Frank DeLuca parking lot is vegetative surfaces. We are using the grass platforms already in place as vegetative surfaces to reduce the flow of storm water into the rain garden. By creating a curb cut in the platforms, it allows the storm water to flow easily from the vegetative surfaces highlighted in red on the slide to the catch basin highlighted in yellow. Our final BMP was a bioswale. In the adjacent lot, we decided it would be best, given the low water table, to implement a bioswale. Based on the stormwater runoff calculations we calculated and to account for larger storms, we created a bioswale with an area of about 1,048 square feet. For this lot, we are suggesting repavement within the design plan. This will ensure a steeper slope to increase water flow into the bioswale as well as reduce stormwater flow from entering the nearby wetland.
So with all three of these BMPs, When it comes to plant selection, it's important to take note of different characteristics for the plants. So this would include general aesthetics, the location in the rain gardens, its bloom time, and of course it being salt tolerant because we are in the Northeast and it does snow and this is a parking lot near a main road. It's also important to note that we are in zone 4, the riparian fringe, so we're about 1 to 4 feet above the normal pool and it is periodically inundated. And the plants could provide shoreline stabilization and habitat for wildlife because we are by a coastal area as well as a wetland. In this chart, you can see all of these different factors. Specifically for bloom time, you can see that we picked plants that were all different seasons so that maintenance wouldn't be as bad. Same with the location in the rain garden. Most of these plants could be located in any parts of the rain garden. And overall, they are mostly salt tolerant so that the chemicals wouldn't affect the plants.
This concludes our presentation on the 3 different types of BMPs that could be implemented in the Frank DeLuca parking lot and the parking lot adjacent to it in Stratford. Thank you so much for your time.